Okay, so I'm Benjamin Crosby. I'm the Director of BIM and Virtual Design and Construction for the Yates Companies. And so I've been in this role for 7 years now, and I've greatly enjoyed it. It's really been fun. It pulls together all the elements of construction and building that I really like. I started off out of school with a really strong emphasis on scheduling because I had an internship and I got to experience managing the schedule, and I saw the benefit of managing the schedule to managing a project. And I saw very early on that I can lose control of the budget and I can still make a schedule on a project. But if I lose control of the schedule, the budget's blown, the quality is blown, the relationships all fall apart, everything is messed up. And so I was focusing heavily on the schedule. And so then, as this thing started coming out, BIM, and I saw where it could fix a bunch of the issues that usually give me schedule problems, then all of a sudden I realized, hey, I can use this tool to supplement all my scheduling and make it better to complete a project on time, in budget, all of those sort of things that are supposed to take place. And so I went from, school, construction management degree, and with an internship, to working for a construction company and being assistant project manager, then project manager, and then a senior manager, and then rolling into this BIM, where now I'm a director and part of the management committee for Yates. And so get to work with all of these issues. The whole time I'm going through all this, BIM and virtual design and construction is not something that justifies itself. Right? Nobody, hey, that's a neat model of a building. Yeah. The next question is, when are we going to build the building? It has to be followed up. Same thing when I'm talking with architects and engineers. Their plans and their design are not something in and of themselves that have worth. Their worth is the end product of actually building the building, the roadway, the dam, the silo, whatever it is that is being built. That is the purpose of the plan and the design and everything else. And we have to keep that in mind all the way through. And so that was a little bit of introduction. I do want to ask you as a group, what are some of your expectations coming in here today? What sort of things do you want me to talk about or address? Ins and outs of BIM. Okay, I can do that. Okay, I can address that. Yes? How in the world does that happen? All right. Okay, I will definitely start out with that. Yes?
I would like for our students to understand the role of BIM in a construction company.
Okay.
I think we would maybe commonly associated with the design or architectural side, but
Okay. I should be able to hit that too. Okay, now if you think of other things as we go, I like the interaction. It makes it better. It drives it home. If you have a question or a thought, let's do it. So let's address this slide real quick here. How does that happen? Okay. So my next question is, what was there first? Was the house there first or the power pole? You think the power pole? Okay. So then they built the whole house. At what point did they look at it and go, right? At what point did they realize we did something stupid? Okay. So did they notice that when, I'm pretty sure they put all the concrete in the ground, they did all the plumbing. I bet you they were framing up the house, and they'd actually started to frame this garage before someone drove up to the project, because their temporary entrance had been over here, they've been parking everything, drove up and looked at the garage and looked at the power pole and facepalmed. Right? Okay, but the idea was they weren't looking at how the plans related back to the actual environment in which they were being done. Now it's such an extremely obvious example, but I've seen so much stuff like that happen on actual projects on a real basis all the time. And so someone was not aware of important information or facts. Ignorance is our enemy. And that's what this whole presentation I put together for National Convention for AGC was the idea that ignorance and chaos are the real enemies. BIM helps to fight those, and it helps to fight it using a team environment. The other side of that is deliberately disregarding information. At one point in time, this was a simple mistake. How many of you have created interior elevations in software? How many of you have done? Okay, all right. So if you're thinking about this elevation and you stop work and you think about this elevation, it takes an extra mental effort to say, what do these two interior elevations look like next to each other? That is an extra step. If you have a design team that is being pressed, go, get it done, get it done, get it done. They're not going to take that extra step. They're going to look at this elevation, they're going to look at this elevation and get it done. Right? There's also a good chance that maybe each of these elevations, maybe at one point in time there was only a urinal here. And then somebody said, no, we want to change the urinal. And they added the urinal over here, but then missed. Maybe it could have been correct on the floor plan and on the plumbing plan and everything else, but that other elevation was still there. Or maybe they corrected both elevations, but then neglected to go back to the plan. See how a software like Revit or ArchiCAD or EcoSim with Bentley, they solve a lot of that problem. They solve that I forgot to correct it here, here, and here. So that, especially by when you graduate and you go out in the industry, we're going to be kind of beyond that aspect of it, which is awesome because as an architect or an engineer or a constructor, that frees up some of that valuable brain power to be thinking about other things on a higher level that could even be more important. Okay. So let's go on to the next one. And if it's going to go twice, all right. We also have chaos. Okay? So what kind of confusion can we have? This simple one, this is a federal prison. Okay? And so prisons have lots of bars on windows and lots of very strong doors and lots of concrete, things that you cannot break, and it works really, really well. So a little bit of confusion. You have a set of plans that then show you setting a door, window, interior window combination. So then the question is, do the bars go on the inside or the outside of that room? Anybody want to take a guess at what you think? Outside? So why would they go on the outside of the room? So once again, a little bit of ignorance. I doubt any of you have built a prison before. So what are the rules? What are we supposed to make that decision? In this case, this room was a counselor's office that is there working with the inmates, helping them get ready to go back into society and things like that. And so, because that is where a civilian worker normally is, it is also considered a safe room. And if something goes wrong, the door swings shut, it gets locked, and they can sit in there for 24 to 48 hours until the whole riot is taken care of. Bars on the outside is exactly what they want. Well, somebody else thought that this was a place you were locking prisoners in, and so if that was a room for a prisoner to stay in, then the bars would have been on the inside like 95% of the rest of the rooms in the building. So how do we know, how do we convey all of these rules? Because we had an architect that was considering every one of those rules, which we could also refer to code, right? And how this is supposed to be built, but then how do we convey that? And that was the confusion. Which way does it go? That was represented on the set of plans we're building with some line weight. And by the time you copy the plans once, or even if you get a halfway decent print, that line weight was gone and it was invisible and cannot be distinguished. So that was the issue there. It caused the confusion. And then there's general disorder when you end up with chaos on a project and things going on. When really what we want is we want order and understanding so we can do things like this. Okay? Now think about that for a minute. The other things were accidents, were mistakes. Does a window get installed slanted like that by mistake? Any of you done any masonry work? Anybody here done masonry? That is a lot of very difficult cuts in brick to put that in. This was somebody's very unique identifying thing they wanted to do with their project. Okay? I mean, it's like, any of you ever been to Wonderworks? First see the plans for Wonderworks, you'd be like, they're upside down? Because the building's supposed to be upside down, right? Same sort of thing here. Okay, the window is supposed to be tilted. But that takes order. That takes understanding, because we have to convey that information well enough that the mason who is doing the work doesn't walk up and say, oh, that's messed up, let me fix it. Well, he wouldn't be fixing it. He would now be deviating from the specifications. And this is the sort of organization that goes into, that's the Jackson Federal Courthouse. They're in Jackson, Mississippi. That was a 6,600-yard concrete pour. We had 4 concrete pumps, a solid 36 hours of continuous concrete going in place, and the order and the organization that has to make that happen. And the biggest issue that we had happen is one of the trucks, as he left the site, went to spin his BIM to keep the concrete spinning with a little bit of leftover that was in there, turned the drum the wrong way and left a little trail of concrete down the interstate. I still know where some of those piles are, because they didn't come completely off. But anyways, that was the biggest hitch that happened, and that wasn't a big deal. We sent somebody behind him with a shovel, and he just scooped it in and cleaned it up. Everything else, nice and smooth. So that's the sort of thing that we're after on a project. And this is the sort of things we're building. That is that courthouse. That is that facility. This is the outlet mall there in Pearl. Have you been there? That was a good project to work on as well. I enjoyed that one. So the idea is BIM starts to build collaboration. Historically, within the design construction industry, this is the relationship that everybody had. Architects, engineers, contractors, the owners, they all kind of fought against each other. The contracts were written to be opposing to each other. You're going to see that when you get out there. One of the things that I've done to fight that is whenever somebody around me, when a contractor starts to try to tell an architect joke, I just tell them no. We don't need to build that relationship. We don't need to go that direction. We need to be coming together. And when architects start to tell contractor jokes, I say, I'm a contractor too. Right? Don't make fun of me. Right? Because we ought to be moving the project. This idea of working together to make things happen. So, with that in mind, the core premise behind BIM is previous to BIM, you would do a concept design, and this is what a lot of you are doing in architectural classes now. And then that design would go out there, and then you get plumbing, electrical shop drawings, plumbing, architectural design, the structural shop drawings, and all those things would be created in order to work out the details of building this building. All the sort of things that it takes to make sure it really happens. But the first time it would come together was when it was actually built. That was your first time to really, yeah, you could overlay sheets, right? You could even overlay in CAD is the next thing that we did to try to make sure it worked, but none of that gave you a true representation. With BIM, we are actually building that composite model. And we are actually working, and that's part of the difference between BIM and virtual design and construction. BIM is the act of creating the model. That's what the software does for you. Virtual design and construction are the steps that take place after that. How do we actually make all this happen? And so if we look at kind of the flow of construction and how it works, you're going to have some contract language that sets the tone for everything that you do on your projects. How that contract is written, whether it is design bid build or integrated project delivery, it makes a huge difference of what takes place on projects. Then from there, some point in time, there's going to be a schematic design, that rough sketch. Now, generally the principals of architectural firms that have built up their company, I think all of them that I've talked to, that's what they really love about architecture, is that highly creative part where they get to take and make the building have a feel and a life to it and be inviting and serve its purpose, all of those sort of things. And then they get into actually creating the design to match that. This is a lot of work and is very difficult and not easy to do, right? And to be able to hold that design and that feel as you go to it, especially when you have an owner that starts saying, well, I've had to cut my budget because of this or that, so it gets very difficult. So you try to maintain that. And then we roll into the shop drawing fabrication phase, where we have to maintain the shop drawings are maintaining the design and the engineering. They can't change the requirements that are there. But what they have to do is find out which pieces and parts do we have to put together to make that requirement happen. And so that's the phase they're in. And then the most important part is actually getting it all assembled. Actually, workers, men and women going out there and actually laying a block or installing conduit like that electro box back there, or coming in afterwards and putting in a camera that's mounted up on the back of the room. All of that work, how do we convey all this information through this process to them? Now, if we want to change our industry and actually be able to build more buildings for less money and have nicer buildings and better buildings, this is what we really have to change, is what's taking place at the installation. That is where the majority of that money is spent. And you also have the idea of what takes place in operations. So have any of you taken any LEAD classes and explored leadership in engineering and design? Okay. So that's something that focuses on the long-term use of the building and the cost payback there. Because if you can reduce the cost of operating, maintaining, and using a building, then that allows you more funds up front to improve the building. So those are the sort of things that we're looking at and we're doing. I'm going to skip a couple. These are two projects that we're currently working on. One of those is much more expensive than the other. Want to guess on which one's more expensive? Okay. But you look at things. So what makes you think that's more expensive? The shape is very custom, right? It's unique, it's special. But if you start designing architecturally, you think about when you do a hotel like this, how many levels do you design here? One or two. What are you going to do there? 42. Right? They're all going to be completely unique and completely different. Because you can't even though the dimensions might be same side to side here as this one up here, Okay, so that's the sort of things that are allowed to do. So what is interesting about these projects is the design team on neither of these projects is using any elements of BIM or virtual design. And they are having a very rough time. So now why? Why would someone not do that? Well, both firms use BIM and they do it all, but both of these projects have been in the works out there trying to be built for like 15 and 20 years. Right? They've been somebody's dream for that long. And so all of the work was previously done using the greatest technology at the time. That's your CAD. But now when it's time to build it, that conversion and rolling over doesn't work very well. And so it doesn't click. And so sometimes even very large projects don't use BIM. Now, personally, I have found that I use BIM on all my projects, including bunk beds for children, and remodeling my home, and putting a new dishwasher in my kitchen. I had to cut out some cabinets, but I model all that stuff. Why? Because there's this old phrase, measure twice, cut once. That's what BIM is doing. It's design once, build once, right? Make sure it's right. Get the design, get the idea and the intent correct, know what your materials are, know all those things. And within Yates Construction, we have no limit on the size of project that utilizes BIM, right? We say that all of them should. Now, even on these ones, even though the design team was not, we are going back in, and obviously from the pictures, we are going back in and modeling it all and putting it back together to find those issues before it comes into play. And we have found very significant issues on both of them to save the clients a lot of money, and that's what we do. On our smaller projects, all of them, the reasons we would not use BIM is like this one. Historically, a whole bunch of the plans were done. Doesn't make much of a difference. The other thing is we look how much are the architects and the engineers participating. That is a factor. Which trade contractors are involved? Can they participate? And so there's things like that. And so we do allow, our goal is to be at 95% of all of our projects all the time using BIM. Right now we're riding about 82%. Okay, there's still too many exceptions. I figure the 5% exceptions is about right. There's always about 5% that's just not going to fit in. But we've got to get that up there. And so some of the projects that don't, they had a rough start. The owner was changing things, it was going back and forth, and it just never really kicked off. In areas, we've had some markets where no one knew anything about BIM. Monroe, Louisiana. No one had ever done anything with it there before when we went in, and built a $125 million corporate headquarters for a Fortune 500 company. So we got to introduce everybody. So I got to spend a lot of time teaching, training, getting the things going. So you can take it into a new group of people, but the core difference is why are we doing BIM? We do it for productivity and efficiency. I don't do it because it's a new technology. I don't even do it because it's the right thing to do it. I do it when it is productive and efficient and it benefits the project. So I'm not going to go out there and tell a project they have to do it. A great example of that was we had a tornado relief program where there was a hospital where their emergency room was no longer serviceable, and so they had to bring in a set of 15 trailers that had emergency room equipment in it, get them all set, put into place. Our job was to pour foundations, stem everything up, and go for it. There was no BIM need for that. It just wasn't going to be useful. So hopefully I answered your question and your question. Let's keep cruising through. Here's an example of something that we do with BIM to avoid ignorance and chaos. This is the Bloomfield Outlet Mall that you saw a picture of earlier, and many of you have probably visited. This is a 4D schedule. We have taken the elements of the model, and we have tied them in a program called Synchro to the actual construction schedule. And you can see the list of activities on the side. And you can see as it's going through, all that stuff is happening and going by really quick. I forgot that I sped this one up, so I talked too long. Right there it is. Okay, right here. Some of you in the back might not be able to see, but we actually saw the project building. I've taken the elements from the models, tied them to the schedule, and now we can actually see the schedule. It's like having a crystal ball. It's amazing. So I take this crystal ball and I go and I show it to the superintendent and say, hey, look, I built the schedule. We have this. This was the first one I really did, some like 7 years ago. It would have been April. It would have been 7 years and 2 weeks ago. And I got all that put together, showed it to the superintendent, and he says, Crosby, you're on schedule and your BIM stuff is all useless. This is all stupid. This is dumb. There's no way we're going to have 5 cranes on this project. Take all your stuff back and redo it. Okay, thank you. I appreciate your feedback. As a side note, that's always the appropriate response to feedback you get somebody, right? Whether they tell you you're an idiot or whatever it is, the appropriate response is thank you. Anyways, we'll get into that later. But thank you very much. And I said, so what I was doing here, and I said, I feel as if we're going to need a crane to set these units. Oh, we're not going to need that big of a crane. Oh, okay, all right, I can change that. My bad. We're good to go there. And then I walked to this building and said, well, the schedule shows that we are erecting precast and setting steel at the same time. I said, are we going to share a crane to do that? He says, no. And then he got it right then. He's a good superintendent. He gets it. He realized I did not put 5 cranes in here. I just followed the schedule and the activities that took a crane have a crane, and then he got it. And he went back out to the job site. They accelerated. When footings early on, they worked double shifts on a bunch of that to get these buildings going faster so that this one would finish in time. So it had 2 cranes on it, and then 2 cranes moved over here. Now, what's significant about that? Well, this is an outlet mall. What day does an outlet mall have to be open? Which weekend? Black Friday. If it's not open on Black Friday, what happens? No sales. What happens? No sales. No money. Does the contractor get paid? Design team get paid? No. Who gets paid if that happens? Lawyers. They're the only ones that are going to be happy in that situation. Everyone else is going to be miserable, right? It's going to fall apart, right? And so there is no delay. Oh, hey, the schedule said, oh, it rained. Oh, there was a tornado, hurricane. No, it has to be open. Nothing else works. We come across projects like that all the time. What if we're building a new dorm for the university here? What if we built a new dorm for you guys? When does it have to be open? On August. If it's not open by August, what do we do? Somebody's paying to put a bunch of students in hotel rooms. And that's expensive. It might be nicer than the dorm, but anyways. So this is the sort of thing that we're looking at and doing. Okay? So here's an example of a 4D schedule. This is also, we use the Oculus Rift and virtualization. And so we actually took our 4D schedule. I picked a spot in time. I picked the busiest day on this campus where we'll be building this project. On that busiest day, this road through here looks like an interstate. There is traffic back and forth both directions on that road all day, the entire day, all night. This facility is cranking away. And we're supposed to be building on their busiest day of the year without interrupting their typical business practices. So this was a screenshot to walk them through that. We've added some safety icons that we help in our training and our orientation. So that way when they're looking at the schedule, they realize we're doing orientation, this is what we're going to be building. We're going to have to be worried about fall protection. We're going to have to be worried about overhead work. We're going to have to be worried about traveling underneath this where there's dirt going back and forth on a conveyor belt. All of those sort of things. We're overcoming that ignorance and chaos by using visualization that you can see. Okay? That image itself was a very significant factor in us winning a very large contract in Tennessee. And so because that is an important scope of work to them. And we walked them through the Oculus Rift. They were able to look at it, and they got on the Oculus Rift, and they looked at it, and they said, this isn't high enough. I said, what do you mean? This isn't a typical road. That being at 16 feet doesn't work. We run tower trucks past here that have to have 18 feet to get clear. Good. I want to know that now before someone drives a tower truck underneath it. All right? And so those are the sort of things that we find and we do. Okay? This is an example from a Mercedes plant where they build Mercedes Sprinter vans. Our shop drawings came in, and they had been modeling like they're supposed to. The coordination between the structural steel and the bar joist and the interior columns. The bar joist was providing some interior lightweight columns. And what we ended up with was a 7.5-inch difference between the two. We found that virtually before they made the steel order, before they did all that, saved the project 6 weeks of time. Because is it better to find it here? Now, you got to know that's Photoshop. You got to know that never happened. For one thing, I know it never happened because you never have a span that close on two ends of anything, right? But it does get the convenience and the idea across of what can happen and does happen. I mean, I showed you those images at the beginning. That sort of stuff happens all the time. So the idea is these whole teams have to work together to make this happen. Previously, our contracts have indicated that all of them would work separately and are generally at each other's throats through a project. Now we have to change that because all of these groups are now engaging in teamwork. Some people openly and readily accept that. Some people really don't like that idea. And so we just work with them and we help them through. Here's an example of what that would look like. This is a corporate headquarters for a Fortune 500 company. So first we had our footings foundations. That is our steel fabricator's model. That is not the engineer's model. This is the fabricator. It's got cross braces. It's got kickers. It's got all that sort of stuff involved in it. Okay, concrete, not a big deal. Okay, custom stair tower, different design. Miscellaneous metals, that's different fabricator. Okay, our ductwork, fire sprinkler, lighting. Okay, curtain wall, glass, glazing, electrical lighting again, finishes, laser scan. Whoa, why would we laser scan where we're well into work? So we have a particular contractor that is going to make this tower through the stairs this glowing tower of light that is absolutely amazing and wonderful to see. Okay, but they tell us that to put the fiberglass panels up, they have to have a tolerance of 1/64 of an inch. Have your classes gotten into tolerances yet? Okay. How many of you have done work that know how big a 1/64 of an inch is? It's smaller than that, right? I mean, we're like fingernail, right? I mean, when you're doing construction, how do you typically mark where something goes? A tape measure and like a chalk? How big is a piece of chalk? How big a line does a piece of chalk make on the ground? Way bigger than a 1/64, right? How do you actually measure down to a 1/64? So for one thing, man, that's crazy. But these are custom fiberglass panels. They have to wrap. They can't have any seams. All this stuff has to take place. So how do we get them their 1/64 of an inch? Well, we laser scan it. And we do a high density laser scan because most laser scans would only get down to like 1/8. Yes, sir. This is a laser scan of the physical construction on that day. You can see there's a lift there, a JLG lift. There's some boxes of supplies. This circle, that is one of the locations where the laser scanner sat on the ground and it doesn't scan underneath itself. So it leaves a little hole. There's another one over there. There's another circle there. They're harder to see, but And so it reads all around, and then we pull all these models together. It collects all the points from all the different angles, and you get this model that you can walk through. That is accurate down to a 64th of an inch. And we go back to that supplier and we say, here is your model, here is how to measure, here is how to know exactly where every bolt hole on those studs on that are at. Okay? And they gave me this deer in headlights look like. So then I start, red flags go up when they're like, ooh, what do we do? And I start finding out and asking some other questions. And I find out that they're fiberglass panels that they make them. And then they get them out and they let them kind of dry. They kind of lay them over some bins. And I'm like, they kind of lay them over some bins? That doesn't sound like 64th of an inch tolerance to me. And then a guy comes and he measures and he marks it with a carpenter's pencil, you know, those big fat pencils, and he drills holes. I'm like, that doesn't sound like 64th of an inch to me. Right? So what I found out is that those panels are fairly hard to make, but how this company had been doing it is they would tell everybody a 64th of an inch tolerance. They'd bring their panels out, they didn't fit, they'd say you're out of tolerance, and make the owner pay to fix the panels. We provided a means that the owner did not pay to fix the panels. So they had to make the panels and put them in and install them, and when they made a mistake, they paid for it. We saved the owner a lot of money. That was a good thing to have happen. For us, that contractor was not too pleased with the situation, but they'd kind of been a little devious there. And that's not acceptable. We want people to do better work, be more productive, be doing things right for the right reasons. Okay? So that's where BIM helped us a little bit. That's the laser scan and the model. There you are, complete with some of the finishes. And then, of course, there's your tower of lights. And so it all ended up being quite nice, looking really neat. The other thing about this that was a big deal that we don't have the story for, those were some of the first circular LED panels ever produced in the world. And they had to do custom displays on them that go around the column and stuff, and they're pretty neat to see too. They did that, and then like 2 years later, all of a sudden curved TVs are like all the rage. But anyways, so it's really pretty neat. So that's the sort of idea we're talking about. So let's walk you through how does this happen and what makes BIM work. We have an architectural design. How many of you have actually produced an architectural design? Okay, that's the starting point. That's the dream. That's the vision for most projects. Unless you're an industrial, if we're doing a processing building that's creating a plastic or fiberglass, then nobody cares about the architecture, right? It's about the mechanics and all those other things. And so, but anyways, model-based, which I think all of you are familiar with. You're all in the classes. You're doing that. That's what it needs to be. Then we have to do the civil. I've had 5 projects within the past year and a half when I went out there and I started trying to virtually align the civil and the architectural and say, how do these sit to each other together? I discovered that nobody knew how they matched up. What kind of consequences does that have in real life? Nobody knew where the building was supposed to go. Right? It's, you know, really ought to know that, especially before we pour the concrete, because we can't just like move the concrete later. Okay? So then we federate them. We make them align. We figure that out. Now, this should all be happening by a design team. They should be setting a model to origin relationship. Some point within that software that the software decides is 0, 0, 0 in an XY coordinate system, and where does the model sit in relation to that point so that everybody else can match with it. Then our structural has to match, our mechanical, electrical, plumbing, sprinkler systems, whatever else we're going to model. Kitchen equipment, CCTV, furnishings. Those all produce the design requirements. They meet the code. They are what has to be built. Then we have to go into this process of how do we actually build it? Because I'm pretty sure all of you that have created architectural models, did any of you bother on where the masonry brick actually sat? Or where the block was? Right? Did you actually look at this joint and say, oh, that's a half joint or a whole joint? What's going on there? Or does it actually intertwine? Or are these separate? Is that a control joint there? All of those sort of things. Usually the architectural team is not into that. Why not? It's a whole nother level of expertise. That's a whole nother career of how to actually make that work. So we need shop drawings. So those shop drawings are often referred to as means and methods. So we start building those means and methods. We want model-based shop drawings, so now we can overlay these models on each other. So architectural, curtain wall, ceiling, doors, flooring. Would we model the flooring in here? It's just paint. We don't really need to model it, right? What's a building where you've seen where you would have to model the flooring? What? A fancy tile floor, if it has a pattern to it, right? You walk into a building and maybe there's a big compass out there with a north on it. It's embarrassing if that's not really pointed north. And so you want to model it to make sure it works. Any of you have visited a casino? Flooring patterns are very significant and important in a casino, right? That's how they keep you at the games, right? That the floor all points back to the roulette table. All right. Steel, concrete joist, masonry, mechanical, electrical, plumbing, sprinkler. These are all, the information is pulled. You have to almost redo them, right? They can't just take these models because these models don't have the detail. They don't have the level of development that's needed when you get over into here. So all of that comes together and you start bringing them in. Every week you bring in what you have and you start coordinating it and you're running it through this process, making sure it works. If it doesn't fit, you go back up and you go through this process in this circle over and over again until you have it completely designed and worked out. With the whole intent of then when someone walks out there to start installing things, they know it all fits, it all works, where it goes. Every one of those employees that are now out there building this building, they have freed up that much brain power to think about, is the quality of my work correct? Am I actually putting the tile, not just is the arrow of my compass on the floor looking north, does it actually look good the way it's coming together? Right? Is my conduit actually straight? You look at that electrical panel right back there. If he'd known everything was going to fit, would they have had those crossing over when they did it? Or would they? No, they would not have. That's an exposed feature. It's there all the time. And so there's things that we can do that much better as we go through. So we are pretty much out of time. I walked through this process in the other class. If you do the process wrong, you're get a plan about as good as Wile E. Coyote. Okay? A little bit better you can do about minion level planning. What I'm after is Batman level planning. I want you to be able to keep the whole world safe through excellent planning. Okay? That's what we're after. Same thing on the contractor side. Right? If we're not doing our shop drawings right, we end up with junk like this. It just doesn't work. And they just pound it in and you end up that. If you do it right, things get real. Like completely, we are virtually there and we know exactly where things go. Right? So, here is a very good example. Once again, that same building I showed you earlier. This is fabrication model. This is the design model in blue. If you look here, you'll notice there is a very large, nice balcony. Our fabricator had not been told there was a balcony coming. Owner went to the architect, we want a balcony. Architect added a balcony, told the structural engineer added a balcony. And then they were producing an ASI that was going to be released on the next week. This was a Wednesday. That ASI was coming to us on Tuesday of the next week. We happen to also be reviewing this on a Wednesday. And notice this because there was 185 linear feet of glass handrail, which was running, I think, about $85 a linear foot. So very expensive stuff that showed up in our glass guy's model. And he was looking at the model. We were helping get quantities. We had this discrepancy. And so we're talking to him. And couldn't figure out what. Finally, we got down to it. We opened the model. We're looking at it. There's this whole glass handrail around a balcony. And everyone in the team with me looking at the models like, where'd the balcony come from? And it was all going to be released to us the next Tuesday. The significant thing about this was that order for the structural steel was going in on Friday. And if you don't make the steel roll and you don't get the order in when everything else is being fabricated, whenever you do that, the next date is usually at best 4 weeks. On a regular basis is 6 weeks, and I've known of 10 weeks when you had to wait another 10 weeks to get the rest of your steel. It would have delayed the whole course of the project. So those are the sort of things that we find. I'm not going to tell all the stories about that. I do want you to walk away from this and keep this in mind with you with all of the new technologies, drones, whatever it is, all of this stuff that's coming out there, right? Uber cars that drive themselves. It's going to change so much faster than it's ever changed before. And I think about my father, who has experienced, who remembers getting indoor plumbing in his home, and remembers getting a generator that had electricity and all that stuff for him to do that, to now, and I think about him having the difficulty he has with a smartphone. He just wants to be able to dial, okay? Right? He doesn't need all that other functionality. He doesn't want all the other functionality. And me, as a younger person, I have a tendency to get a little frustrated sometimes. Why don't you just... Well, my dad knows a whole lot more about his line of work and what he does than I will ever be able to know. He spent his efforts learning something different. I think about that. Okay? Then I think about how much it's going to change for me over the next 40 years and what changes I'm going to see by the time I'm 82. And then you start to think about what this world might look like when you're 82. You will not be able to keep up either. Okay? So don't think that for some reason, because you're up to speed on this technology, you know how to navigate social media, all those things, that you know something more than that principal of the architectural firm that you're going to go work for. Okay? Keep that in mind. You have a different set of experiences and different set of learning. Use that different set of learning, but don't be arrogant enough to discredit somebody else that's learned a different set of things. Cool does not do it. You've got to be thinking productivity, efficiency. How do we actually do this better than we've ever done it before? And keep that in mind. I say this all the time in my meetings, my presentations, my classes. Finally, after it took like 4 years, maybe 5 years, and I don't get emails from anybody in my company anymore that says, this is cool, look at it. I get emails now that say, this can help us make better quality inspections on the project. This can help us be safer. And they're giving me real purpose and intent. I challenge you, all of the stuff in your life, be thinking about that. Is this just cool, or is it actually making you better at what you do? All right. I'm not going to get into the rest. We're out of time. Thank you.
You didn't push record? There was something wrong with the computer, but I got it in the camera.
Okay. Well, that's good that you have it in the camera. We'll have to figure out how to exchange files, Dropbox or something. I'm quite curious to see.
Here it is. It got it.